Okay, so I'm now ready to move on to the first stage of the transmission side of this radio, and that is this transmit mixer here. So if you'll notice, this is very similar to the transmit mixers that I've done myself with my own sort of homebrew stuff. The difference being is the PCM 3060 is actually providing, so the PCM 3060 gets the I and the Q signals from HDSDR. But the audio codec provides a 0 and 180 degree version of those signals. So you don't have to have that sort of op-amp network that I had that split the signal into a 0 and 180 degree version. The op-amps here are Texas Instruments TLV 2464. It's a quad op-amp package, and I'll provide a link to the datasheet. The op-amps themselves provide just buffering. There's no gain in this stage at all. You can see here there's just a pair of 10K resistors here, so no gain in this stage. I believe this cap here is just to provide some attenuation for high frequency signals. And then it passes through the, you've seen this before, the sort of there's an electrolytic cap here, and then this combination of a 49.9 ohm resistor and the 0.022 microfarad capacitor. So this effectively provides a low pass filter here. One note is that the board outline, and let me just show you that while I'm here. So the board outline has a spot for electrolytics, but the bill of materials says tantalums. So a little bit of a difference there. I might actually try with electrodes here. Just give it a go, and then I could swap out and put in tantalums and see if there's any difference there. Just moving along, here's that FST 3253. Again, the BOM requires a 74 CBT 3253 here, and this is that kind of that standard signal where you've got basically you do the mixing here. It's a direct conversion mixer. Out here is the RF signal. Now this RF signal has either the upper or the lower sideband suppressed, depending, of course, on the input that it gets from HDSDR. Signal then passes through this combiner here, and then this goes off to the bandpass filters. So this set of bandpass filters goes here, and then that that basically only allows the frequency of interest through. So what I'll be doing is I'll actually be testing on the other side of the bandpass filters. I should be able to see a nice clean single sideband signal on the other side of the bandpass filters. So that will be the easy way of testing this. I'll come back when this is built up, and we'll do some testing. So I thought it'd be good to go through where I'm actually going to be testing. So this is the other side of the bandpass filters are right here. So the filtered signal comes through here, gets split by this transformer here, and then this resistor here, what I'll do is I'll install this resistor, and then I should be able to use this as my test point here. I will have to include this this circuitry right here, which is comes from 12 volts, and then we've got this Zener here to do some very simple regulation. So I'll get this installed, I'll get this resistor installed, and then I'll be able to probe right here and see that signal. So anyway, that's to come. Before I get that all together, let me just quickly go over to the board and show where all this is. Okay, so all that goes onto the board right here and occupies this section here. So this is where the I and the Q audio signals comes in. We've got that network of 10K resistors here. Here's where those 100 picofarad capacitors go. There's the TLV 2464 quad op amp. Here's the four, well, obviously this is an outline for an electrolytic here, which is what I'll be using, but the bill of materials says tantalums here. And then you have, here is the input into the FST 3253 or 74 CBT 3253 right here. It's a pair of 49.9 ohm resistors right here, which I'll be using 51 ohm resistors. Here's the combiner that goes into the bandpass filter. And then on the other side, on the output side, here's the splitter, which takes that signal, splits it into two halves, and then R56 is actually on the other side of the board. So if we have a look, let me get it up the right way, bear with me. So let me see if I can find it. Sorry, R58 is the one we're after. So here's that 200 ohm resistor. So I'll be able to probe either side of that. I should see a single sideband signal. And then all the rest of this is the next stage of the transmitter, which I'll cover in a subsequent video. So anyway, that's the plan of action. Get that all together. Should be able to do some either speak or send a tone into HDSDR. We should be able to see a single sideband signal on the other side. All right, so let me get that together and I'll come back. It's a bit of a change of plan. What I thought I'd do is get this op amp and the resistors and capacitors around it installed, and then I can probe the output side here. So I should see, for example, on C29 and 30, so 29 and 30 are a pair, and these two are a pair too. So I should be able to see here and here. I should be able to see an audio signal there, and they should be 180 degrees offset. Same for here and here. And then if I compare, for example, this one and this one, I should see a 90 degree offset from these two here. So I think this will be a good test point. It'll sort of prove all this is working, that all the audio processing from HDSDR through the audio codec is all working, and then I can move on to the next stage, knowing that this audio, at least the audio input, is working correctly. So let me set up that test, and we'll come back and test that. Okay, so I've got my test set up, and you can see I'm probing on C30 and C32. So I should see a 90 degree difference in the audio signals from these two here. These are the caps on the I and the Q respectively. So let me do that. I've got a tone generator on my laptop. I'll kick off the tone generator, and I'll have the camera pointing at the oscilloscope so you can see the results. One important thing, if you want to do this type of test, is you have to have the local oscillator frequency 0 offset from the tuned frequency if you wish to do this. Now, you don't want to run the radio this way. It's kind of not a good thing. The way you do that is you go into MISC options, set LO tune offset, and you can see there it's 0. So I've got HDSDR on the left here. I'm going to hit the transmit. I've got my tone generator here. There's my tone generator, and I'll go over to the oscilloscope, and you should see those 90 degree offset audio signals. Okay, so it's going to get noisy with that tone. Unfortunately, there's nothing I can do about that. So let me hit transmit, and now hit the tone. And so you can see there, we've got that lovely 90 degree offset signals coming out of where I'm probing. You can see it's at 1 kilohertz up here. So all looking good. Let me just change the frequencies around a bit, and you should be able to see that too. So that's basically the two signals in quadrature. You can see it's actually reacting to my voice. I forgot to turn the transmitter off. Bear with me. So what I'll do now is I'll probe at the 180 degree pairs, and we should see a 180 degree offset between those audio signals. Okay, so now I'm probing at capacitors C29 and C30. And so what we should see here is two audio signals at 1 kilo, well in this case 500 hertz, offset by 180 degrees. So there you have it. Let me just turn off transmit for a moment. So there you have it. We've got the two signals here. You can see it's at 500 hertz, and they're indeed offset by 180 degrees. So that basically confirms that everything is correct up to and including the TLV 2464 op amp. So now I can move on to the mixer itself, get those caps installed, get the mixer installed and the two balunds either side of the bandpass filters, and we should be able to see a single sideband signal. Okay, so I think I've finally got this all on and working. Had quite a few difficulties with this. The first thing I'd forgotten to do is there's some bias circuitry that basically sets 2.5 volts at the center tap of T3, and I'd forgotten to install these components on the reverse here, so that this is what goes up into making up that resistive divider for the center tap of T3. The next problem I had encountered is I was getting what looked like AM out of here, and then after probing around here, I noticed that one of these lines, this one in particular, was low. And on closer inspection, I found that the solder joint right here was tenuous at best. So looks like it's all together now. Just to sort of go through the test setup, as I said, I was originally going to put T4 in and then probe on the other side. I thought what I'd simply do is just put a 47 ohm resistor across the other side of T4, and so I'll be probing right here to see the output signal. So anyway, let me get that set up and come back. Okay, so I think I'm finally ready to test now. Had to fiddle around quite a bit. So first thing, on TX, you want to have, so you have to press TX to get into the TX configuration. You have to have swap I and Q channels for TX output. That has to be enabled. So that's the first thing. Second thing is, again, like the other tests, I've set the LO and the tune frequencies to have 0 offset. So let's just get rid of that. So if you go into MISC options, set LO tune offset should be 0. And then let's move over to the input and see that. One of the things I wanted to make sure is I had a fairly pure tone on the input. So what I've basically done is sent the output of my signal generator to the microphone input on my laptop here, and then again just going back to sound card options, TX input from microphone, I've set that to Microsoft Sound Mapper. Couldn't get any of the other ones to work, but this does work. Okay, so let's click on transmit, have a look at the oscilloscope. So LO and tune are both set to 14 megahertz. I'm injecting a 700 hertz tone, and I'm upper sideband, so we should see 14 megahertz plus 700 hertz on the output there. And if you have a look at that, that is indeed correct. So let me go to lower sideband now, and I should see 14 megahertz minus 700 hertz on the output. And there we are, 13.9993. So let's, just for some fun, let's do the old two-tone test. So I'll do 1700 and 1900. And there we are. And you can see the two-tone test is not too bad. Should see a clean crossover point there, which we're kind of seeing. There's a little bit of distortion at the crossover point there. And now finally, let's I've gone down to 7 megahertz now. I'll do the same thing. Well, let me actually do go up a little bit to 1 kilohertz on channel 1, channel 2. Bear with me. So, all right, let me hit transmit. I'm on lower sideband here, so as you can see, 6.9990. Let me go to upper sideband, and there we have 7.001 megahertz. So that basically confirms let's just pan down to the Magnis so we can see that. So that basically confirms that the mixer section is all working fine. So here's the this is the actual start of the pre-drivers, which are on the other side of the board. Those OPA 2476 pair of ICs are underneath there. So what I'll do, this video is getting a bit long, so I'm going to wrap this here, and then hopefully we'll only have one more video to go, and that will wrap up the pre-driver and then the finals, and we should be able to get this radio on the air. So that's all for now.